So as I said, we'll look at maybe 5 questions from here. And of course, these 5 questions have sub-questions that they have. Yeah. And for question one, they're telling us let U be equal to this set, which is just a set from 1 to 10. And the set A, which is that set there, and the set B given there, and set C that is given. Then they're telling us to find the following sets. So to find, first of all, we must find, we have A intersection B complements, then I have a complement outside there. So I must find this. And how do I find this? I can distribute this complement throughout, and by De Morgan's law, I'm just going to end up to have A complement, the intersection sign flips and becomes union. Then I have there the complement multiplied by complement just gives me B. So I have means that I am finding A complement union B. So now when finding A complement union B, I must then find my A complement. Yes, of course, I have my B. I need to find my A complement. So by definition, A complement consists of all elements that are not in the set A but sit in the universal set. So when we check our set A has the values. So our set A has the values, that is 1, 3, 6, 8, and 10. These are the values that are in set A. Then now they're telling us A complement. So A complement, for A complement, all those that are not in set A but are in the universal set. So if I check closely with my universal set, which is U, I'll see that the first element which is not there is 2. Then I'll go on. 4 is not there. So then the other element which is not there is 5. And 5 is not there. And then I have 7 and 9 not being in that. So these are what will sit in A complement. So I have A complement and I have my B complement, which means this is just going to be, if I get my A complement, which I've just found, okay, my A complement, which I've just found, and that is just 2, 4, 5, 7, and 9. These here, this is my A complement. These are the elements that are not in the set, in the set A. Then my B, if I check what my B is given, there's 1 there, there's 4, there's 6, and there's 10. Okay, if you're not speaking, kindly mute your mic. Okay. All right, but if you have a question, just unmute and speak. All right, so we continue. So we're saying this is what we are doing, and by the set operation union, we just combine these sets, all the elements of what of these sets. So if I start listing there, I have 1 in that set. I combine with the other one there, the other element which follows is 2. Then I have 4 going to follow there. Then I have 5, 6, 7. I'll have 9 and 10. So this here is what is going to just fall into that A complement union B. And this is the same as the A intersect B complement in the complement outside there. So this is our final answer that which we get. All right, let's move on to part 2. And part 2 of the questions. So not part 2, but part B of these questions here that are here. For part B, allow me to erase this. Okay, so part B. My part B, I have there's A complement union B, then the complement is outside there. So I do the same here. So what am I going to do here? All right, so just a minute. Let's go back to the first one we did. We need to correct something. Okay, so this is this set here which we got. This is set C and not B. Yeah, I didn't see that clearly. So this is so I'll set B. If you check the question, it's 2, 4, 6, and 8. So that's the reason why I need feedback from you guys. Yeah, you didn't see that I used the wrong set. So that's what is in set B. Or say we're talking of B and not C. So bringing these together, then I have 2, 4, 5, 6, 7, and 7, 8, and 9. This is what is going to sit in my set. So this is what is going to be in my set. All right, let's then move on to part 2 or part B of these questions. So now with part B, um, they're just telling me to find A complement union, B then complement. And of course, this is the same as saying when I distribute that complement, I'll have A here, the sign flips, then this becomes intersection, then I'll have my B complement. So it's the same thing we had, but then there's intersection here and the complement is at B now. So how do I do this? Meaning I have to have my B complement. So B complement, the set B, if you check your set B, it has the elements 2, 4, it has 2, 4, 6, and 8. 2, 4, 6, and 8. These are the elements not in B. So in B complement, elements that are not in B but sit in the universal set, that is going to be 1, 3. I'll have that 5 will sit there. I'll have 7. I'll have 9 and 10. So these are going to be in the B complement. And this being in my B complement, I already have my A. So I can list down my A. My A is 1, 3 here, 6, 8, and 10. This is what I have in A. Then they're telling me intersect with B complement, which is just 1, 3, 5, 7, 9, and 10. So this is what is there in the set. Now, the intersection is what is common in both of these sets. So what is common, if I check, I have 1 there, I have 1 there. I have 3 here, 3 is also there. And what other thing is common here? Other element is 10. So I have 10 here and 10 there, and I can just conclude this here. So this here is my A complement union B complement. So this is what sits in my set. Okay, let's go on to part 3. So part 3, remember if you have any question along the way, just ask. So with part 3, yeah, we have to list down A intersect B union C. A intersect B union C, and from this here we already. So how do we do this? A intersect B union C. So I first have to find my A intersect B. So A intersect B is just going to be equal to, so I get and list down the first set that I have, which is set A. Set A is 1, 3, 6, 8, and 10. This is what I have. Then intersect B, my B is 2, 4, 6, and 8. So this is what I have in B. Now, to intersect, what elements are common in both of these sets? Closely check, I have 6 there, I have 6 there. So 6 is going to be there. I have 8 there, I have 8 there, and 8 is going to be there. So this is in the intersection of A and B. So I have this first part, which is A intersect B. Now I have to just bring all the elements together with that of C to make this set, which is A intersect B union 1 union C. So meaning I have A intersect B union C. The first part A intersect B intersect B is just 6, 8. Then union C. My union C, what is my C? My C is 1, 4, 6, 10. This is what I have. And union just means combining all these elements together. And I'll see I just combine, I have 1 there, a 4, a 6, then I have 8. Then 10 will come there at the end. And this is what I'll have in my A intersect B union what? Union C. This is the final answer. Okay, we move on to part. Okay, we move on to part 4. Just a moment, I erase this. So part 4, kind of the same thing that we're just moving around here, and we just say A union B intersect C. So key, first find A union B, and A union B just means I'm bringing all elements of A and B together. So with my A, I have 1, 3, 6, 8, and 10. Then union, my B is 2, 4, 6, 2, 4, 6, and 8. This is what I have. Now bringing all this together, I'll have 1, 2 there. I have 3 come, 4, 6, I have 8, and I'll have what? 10. So this is my A union what? Union B. Then this is intersecting with the set what? With the set C. If you check, so A union B intersect C. So I list down my A union B, which is what I just from finding there, like that. Then intersect C. What is my C? So my C is 1, 4, 6, and 10. This is what I have in my C. So what elements are common in both of these sets? You check, there's 1 there, there's also 1 the other side. So I write that there. There's 4 there, there's 4 there. So I write that 6. 6 is in both sets. I have 10 there and 10 there. So 10 is going to sit in both of these sets. And this here is the final answer for this question. All right. Let's move on to question 2. To question 2 of these questions. So if you have any question here, is there any question before I move on? All right, there's no question. So we move on to these, and these are just telling us to express each of the following in its simplest form. So how do we express that in its simplest form? It's more easier to visualize them as like you actually drawing out the sets even in a Venn diagram, of which I will do here just to illustrate some of this. So to start with, the first one, you have that it's P complement union, then you have Q minus, which is the set difference here, close, then you have your complement there. So to simplify this, you can say, first of all, you distribute this complement which is outside. So when you distribute that complement outside, it multiplies with this complement, so the complement goes. Then this sign changes from union to intersection. So you have intersection here, and you have Q minus R there, then the complement comes here. So I can deal with what is inside here in this bracket. I have A intersect, then I have Q. This means A intersect intersect R, A intersect R, complement like that. Then I have another complement there. Then I can multiply this complement, which is outside here, with this one, or throughout, I mean. So you have A, P intersect, so you have P intersect, and you have Q complement, because they're multiplying. The sign flips to union. Then you have this complement multiplying the complement. It's going to give you R, like this. So this is what you get. This is what you get. And picture this then in a Venn diagram. Picture this in a Venn diagram. You have 3 sets. Okay, you have 3 sets, and these sets, you say, let's say we have our P to be here, and we have our Q, and we have our R there, and our universal set. So inside here, you have P complement union R. So key, what is your Q complement? So Q complement, I'll shade the Q complement in white. So Q complement just means everything that is not in the set Q but sits in the universal set. So meaning everything outside what? Q. So this here in white, apart from the set Q, is going to be my Q complement. So this is my Q complement. Then they are saying union. So I bring this U complement with the entire set of what? Of R. So it's saying union what? Union R. So I bring this together with what? With R. So I'll shade also R in what? In white. So meaning this part of R, since it's union, I'll also bring this part in part of this together with the complement. So this entire thing that is shaded here in white is this part, my Q complement union what? Union R. Then they're telling you that this what you've shaded here should intersect with what? With P. So now you check, where does this intersect with what? With the set P. So how you check that, where this intersects with this entire thing intersects with the set P is so you shade. Okay, so you're going to shade your set P, and so I'll use yellow for this one. So I'll go this way, and I'll go that way. Go this way, and I'll go that way. So now, yeah, you see here, you look at where do these lines kind of cross? Where do these lines all kind of meet up? So you see that these lines are interlinked here. Okay, so let me draw this separately. Yeah, see where these lines are interlinked. You have your Q there, you have your R, and you have your P, and E there. Shade this in white. So you see that where it is crossing. So we had said that union R, so we brought R, the entire R into the what, and of course complement there, which was, yeah, and then we introduced in the intersection here with what, with P, and we clearly can see that it's this part here that is crossing, and this part there that is what, that is crossing. These are kind of the two parts that are crossing. So when you look at it, you have more of your P intersect R, which is the entire part, and you have the set here of P and like a small portion of what, of R, that is intersecting there. So if you please, you would expand or write this where you okay, so what we are talking of is P intersect here, QR, like that. Then union, if you use the distributive law here, you have P intersect what? Intersect R. So your P intersect R, as you can see, is this part here. This is your P intersect R here, like that. That's your P intersect R. Then this part here where we have our Q complement, then Q complement intersect P. So everything outside what, then you see where does that intersect with P, and it is this side where it intersects with P. So this describes what you have here. So ending it here is just okay. So ending it here from what you've seen, because here we've expanded again. So this here, which we've written in white, we've expanded because of what we're trying to see here. So means ending it here where you have P intersect QR union R here. I mean P intersect Q complement union R here is just going to be fine there. All right, I don't know if I have any questions here as I move on to the next one. Okay, so let's look at the next one. Okay, so with the next one, we have our set. So our set part 2 is X union, then you have Y intersect X, like that. This is what you have. Intersect there and union outside there. So how can you simplify this further on? If you want do, you can okay, I don't want to say you can expand, but that would help you to shade. But even if you can see this and say you have these sets, in fact, there are two sets, not even, let me not take in what, yeah, there are two sets. There's only X and there's what? There's Y. So inside here, you have what? You have Y intersect X. And Y intersect X is just this middle part here. Then they're telling you union what? Union X. So meaning you bring all the elements even of X together. So this here, including. So everything now I've shaded in what? In red. And from this, you just go directly and see that the shaded region or what you're describing here just can be simplified off to what? To x, saying just get the entire, because this is the entire set of what? Of x. So this is how you simplify this one. Okay, let's go on and move on to part to part uh, to part three. So part three, you have m intersect n like that, union, you have m intersect n complement. This is what you have. You have these two sets here that are there. So one thing you can notice is what you have here in between there and there, you have an intersection. Actually, you can see that you have something that is very common in, or that is common in both of them. That is M intersect. So you would observe at first, just at first glance, that these here, they are distributed. They had expanded this using the distributive uh, laws. So now, because of that, you can factor out your M intersect like this, and then you see that you just remain with N union N complement. Yeah, this is what you have. M intersect N union N complement. So now, if I have my set, so I'll just write this set alone. I say I have the set N alone. Of course, I know it's being intersected with M, meaning M is part of it, but let's just focus on N alone. Then they're telling you N, so this is the set N, which is inside, then union what? N complement. So this here, shaded in yellow, is the set N. Then the complement is everything outside there, like that. That is the what you have there. So this is what you're going to get. Then when you look at this, and this is the universal set, of course. So when you look at, because they are saying union, so meaning all this is being brought together, meaning it's the entire universal set. And if you are able to see this, meaning this is going to simplify where I have M here intersect what? E, which is the universal set. So now any set here intersecting with the universal set is just going to be the set itself. So M intersect E is just going to equal to what? To M. And really you can check that. You have your Venn diagram, this Venn diagram. And this time around, let me draw both sets where I have M and N. So this is M, this is N, and this here is the universal set. So they said this part here where we have N union N complement. So that is going to be this entire thing here. Okay. In fact, it's going to be the entire thing like this. That's going to be your N union N complement. And I see it's just the universal set. Then they're telling me intersect what? Intersect that with the set M. So when I intersect with the set M, so where the set M is, I will shade that set M like that. And I see that the lines, they're crossing what? At the entire set of M. So in short, what I'm just looking for is the set what? M. And that's how I simplify it to that. All right. Part 4. If there are no questions, we move on to part 4. And part 4, what we have is, so part 4, you have A minus B there. Then you have this is going to be A. If I had to write that, rewrite, that's intersect. Then A inside as well, I can write that as intersect. B complement, then outside there, because of this intersection here, the complement is there. Then I can distribute that complement. So I've distribute the complements. Inside I have A complement, the sign flips to union, then I get B there. So this is what I'm going to have. Now, I can make this more easier for me to see when I expand this where I distribute and say I have A intersect A complement like this, then union, I have A intersect what? B. So now this here, looking at the set laws, you remember this A intersect A complement is just going to give you the empty set. See that if I have this is my Venn diagram with the set A. So this is the set A here, and the complement of A is just outside there. And they're telling you, where do these intersect? They don't intersect at any point. You see, the lines don't cross at any point. So meaning that this part of the set is just empty. Then we have this union, A intersect what? B. So bring together, in short, A intersect what? Intersect B. And I know if I had, so I have the empty set, and A intersect B is just this part. Have A and have B there. So A intersect B. So you bring all these together. And this is just going to give you that you have A intersect B. So this here is how you simplify it to that extent. All right, let's do the last two questions for this part. And yeah, so the last two questions, what do I have? So I have that, okay, do I have the other question? Okay, all right, so then I have A, thank you for that comment, noted, thank you very much. A intersect B complement, then I have union, and I have A minus B, like that, then complement. So as I said, the meeting might run out. Just rejoin using the link. Yes, the same link, just rejoin using, yeah, the same link. So now with this one, how do I go about it? I do the same. I have a complement outside here. So that complement will distribute with this complement there. So meaning that it more of cancels out that complement, and I have A intersect B, the complement goes, the sign flips to intersection, then you have A. Inside here, I can rewrite what I have inside as intersect B complement, then the complement is going to be there outside. Then with these two inclusions here that are here, what can I do next? So what I can do next is, okay, so what I do next is I have this part here where my right side here, I can multiply that complement throughout. So I have B here intersect, and I multiply the complement, I have A complement union here. Notice you have union and you have what? You have B there. So this is what you're going to get. Now you have two sets. Check this. You have two sets, A and B, sitting there. So this is my A and this is my B. So I just want you to check the right side. So they're saying A complement. So I'll shade my A complement in what? In white. So outside this here, like that. This is your A complement. And from here, uh, they're saying union what? Union the set B. Set B is going to be that there. That's where this is uniting, is bringing everything together. But then there's this part here that says intersect. Then you're telling to intersect the set A intersect B. So where is A intersect B? A intersect B is just here in between. So in between here, they cross there. So in between there, they cross. So and when I check where those lines are kind of crossing, that is just at what? At A intersect B. So meaning I have my A intersect B as just the uh, final, yeah, set there that I'm going to end up with. Okay, the question, I have a question. There's a question, why have you left out the complement of the left part? Okay, where of the left part? Cecilia, kindly tell us where exactly is you're asking. Left part of this part here, or is it where we are from shading? You can unmute your mic and just, Go on.
So there are two parts, A union B complement A A complement B. Now, why have you left out from the one which is on the left side, the complement?
Okay, this part here,
Mm.
why we left out this part?
Mm.
Okay, so what we did, remember there's this complement here outside, and there are these square brackets here. So that complement multiplies with this complement, and that's how that complement goes. Remember that set law where you multiply complement by complement, it just gives you the original set. So, which is just A intersect B. That's the reason why we don't have the complements there. And because we're distributing this complement here, and by De Morgan's law, meaning our sign here is going to change to intersection, from union to intersection. Then when we distribute it to here, we'll see that this is the one we're having here outside. Then what is inside here? I've rewritten A minus B just to be, this is the same as A intersect B complement, which is what we have inside here. Yes, and this complement, which is outside, is the one which we multiplied here to be there. I guess it's clear now. Is that clear? Are we safe to go? Okay. All right. So we are safe to go. So this is where we arrive at. We arrive at the A intersect B. All right. So now we do the last part, which is that one, 6. Okay. So 6. How do we go about 6? Kind of a similar approach, in fact, to everything that we've been doing. So 6 is just B complement intersect, then you have A union B. B complement intersect A union B. How do we handle that one? Okay, not something to worry about. And so when you check this, you have A union B, and your A union B, of course, if you have your set, your Venn diagram there, and you have two parts, A and B. A union B is just this here, the entire set. Then they're telling you intersect B complement. So now let's shade B complement. Let's shade B complement. So B complement is everything outside the set B. So everything outside the set B, I'm going to have that there, like that, all the way up to there. That's what I'm going to get. Everything outside the set B. I'm not going to shade set B, but everything just outside the set B. And what does that give me? Okay, what does that simplify to? You can see it better because they're telling you to simplify here. So multiply this throughout where you have B complement intersect A like this. Yes, and union. You get union, then you have B complement intersect B. B complement intersect B. Yeah, you have it like this. So what we've shaded, in fact, is just this part here. Because when you look at this, your B complement intersect A here will come, but union here, B complement intersect B. The set B complement and the set B do not intersect anywhere. That is an empty set. So which means that union here, we're uniting the empty set. And when you unite that, you just have B complement intersect A. So this here is going to be our final answer. So that is the part where the lines cross it, those lines cross. And if you just write it separately, you have A and B there. That part is just this one here. This part here, all the way like that. That's that part which we found. Okay. So this is where this end. Do I have any question here? Which one is preferred, either A intersect B or okay, so whichever you're going to use. So here where you have A, so remember this last part, you can write this as A intersect B. Sets here, the intersection is commutative. Whether you write the other way around, it's going to be it's the same. So the complement is here, and this is the same as saying A minus B. Even if you conclude here and just write A minus B as your answer, they will not mark you wrong. This is correct. So whichever you use, it means the same thing. What this means is in set beta notation, if I write this, it's just a set of OX such that X is a member of the set A and X is not a member of the set B. That's what that means. So whichever way you're going to write it. All right. So yeah. And B, they're telling us these are disjoint sets. There are two disjoint sets, and one. Okay. So them being disjoint sets, I have one set there and one set there. So what they mean, if they're disjoint sets, it means that A intersect B is just equal to A intersect B is just equal to the empty set. A intersect B is just equal to the empty set. And so I have they're telling me to simplify each of the following sets. So A intersect B. In fact, we've already done this one. A intersect B is just equal to the empty set. So A intersect B is just going to be the empty set because they're disjoint sets. Then A union B, what is going to be A union B? So if I check this here is it's going to be my A, and I have that this here is going to be I have my A and I have my B. And A union B just means I'm bringing all these elements together. So all these elements together, but when I observe, there's no further way I can go here. It's just going to be A union B because of course I might have some elements that might sit in the universal set, but they're not part of the union of me bringing these sets together. So for A union B just goes to A union B. And then I have the ones that follow. A complement intersect B. So I check what is from these sets that I have, what is my A complement intersect B. So I have my A and my B there. So A, B. So my A complements everything outside the set A, which is going to be there, including B. Then they're telling me intersect what? Intersect B. So when I check what does this intersect with B, that is B. Where it crosses with B, that's just the set B. And this means that will just be equal to set B. Then on the other one, I have A. This is what they're telling me. And that's the same as A intersect B complement. And when you check, the complement has just moved to there. So this is just going to be the opposite of the other one. Where we got B, here we just get A. So this is what we'll conclude. Our answer is going to be. Then the last part here, which is V, the last part there, you have A union B, then minus B. And of course, this is the same as A union B intersect B complement. So what is that going to just lead up to? You can even, so this here, let me write it like this so that it's easier for us to actually see. If I write B complement here intersects A union B front, then I distribute this, I get A intersect so B complement intersect A like this, then I have union, then I have B complement union B like this. Then you check these sets that are here. How is it going to be? So I take you back to this diagram, the Venn diagram, the unshaded one, which I had 1, 2, have A, B there. So B is his B complement. B complement is everything outside B again. So that's gonna be that. So if I take a look at where do these, oh, this here has to be intersection, sorry. This has to be intersection in between here because we've distributed intersection here, not union. So having said that, let's just draw this again. If you draw that, you have, okay, so you have your A and your B. So this is your B. Your B complement is outside here. Then they're telling you you have B complement intersect A. And from that, from what we've drawn here, you see that these do not intersect at any point. So this is just going to be the empty set. And you have union. And this side, you have A intersect B complement. So the one we shaded in white is the B complement. Then they're saying we're intersecting with what? The set A. So I shade the set A. So they cross here at the set A. That's where those lines meet. So I mean, that's why they intersect. And I have A here. So A union, the empty set, is just going to give me the set A. And this is what I get for that last part. That's what I get for the last part. Okay. With these ones are easy. So what you do, they're telling you to display these on an interval on the rule line. And by the rule line, you must understand they're just talking of a number line. And the number line goes from negative infinity to positive infinity because for this time, they're just talking of a rule line, like in general, the set R real numbers there. So the first one, what you must know for this is when you have an open, like you have this kind of a bracket, it means that that number which is on this side, so where A is, like A here, will not be part of the interval. If you have a closed, like you have a square bracket here, meaning it's closed there, it means that B is part of what? Of the interval which you're talking about. So with part one, so we have this going from negative infinity to positive infinity. Then they're telling us negative 1 and 1. So just write negative 1 here and I'll write 1. And they're telling me to display that. So they are closed. There's a square bracket on both sides. So meaning I shade in both sides of the points and have a line connecting them here. Yeah, so it's closed at both sides like that. So this is for A, for this interval, which is negative 1, 1. Then the one that follows, so the one that follows, I just have I have negative 4 and 1. Yes, you can be moving the points just I don't know, like based on distance, but still going to be the same. Yeah, you have that there. And at negative 4, it is open. So you have an open interval there. Then all the way up to 1, it is closed. And you shade in there at 1 where it is closed. Then for the next one, what you do, it's the same, but you see at 1, it is open this time. So you'd open there. Then the one that follows, let me erase this. So the one that follows, you have negative 1, and it's going all the way up toward positive infinity. So it's open at negative 1 because it's an open square here. Even there, it's open. So at infinity, it's always going to be open because we don't know what infinity is. So then there, it's just a line that goes all the way. So this arrow just tells you it's going up to infinity like that. And do the same for the next one, which is just going to be, okay, so the next one you have that's they're telling you 0 to infinity. So to negative infinity. So if our 0 is here, negative infinity is the other side. It is closed at 0, so we close at 0, then going all the way like that. So this is what you have, and this is how you get through this question 4. Question 5, which is the last question for our class today. Question 5 is telling us, where possible, write each of the following intervals in set builder notation. Write each of the following intervals in set builder notation. So for the first one, A, you would write A as, so you say the set of OX such that, so the interval that we have, it is open at 10 here, it's open, and it is closed at what, it's open at negative 10 and closed at 10. So that's the set of OX such that I'll write negative 10. At 10 here, I'll leave an open interval of the less than, then X in between, then where it is closed, I'll put A less than or equal to, then 10, and of course, because it's an interval, it's something that we're displaying on the rule line. So meaning X has to be a number or a member, a member of the real numbers. So this is what you get for A. For B, so you continue, just do the same. For B, so if you want, you can start with saying X is a member of the real numbers, such that, then you write now the interval. So at 4, it is closed there, there's an equal to, then X there equal to 9, like that. Then you'd close it there like that. For C, kind of the same thing, X such that it's from -1 less than X less than or equal to 5, because it is closed there at 5. Then you say X is a member of the real numbers. Then for the last one, D, our last question, we said D has the interval 0, it's closed at 0 all the way up to infinity. So how do we write that one? So you'd say X is a member of course, the real numbers, such that your X is what? It's closed at X. It's greater than or equal to 0. So like that. And this is how you'd finish. So even if you'd have written D is equal to X such that X is greater than or equal to 0, X is a real number, same thing. And so this is how you'd write this. So this means all X values from 0 going all the way this side, which is infinity. Yeah. Okay, do I have any questions? So this is where we end with today's class. Do we have any questions?